In this video, we'll be covering the second half of solving absolute value inequalities. First, let's review the steps to solve an absolute value inequality. First, you're going to wrap up the absolute value bars into a present and solve to get the present by itself. And that's going to be the key difference in what we're doing today. Then you're going to write two separate inequalities. You're going to write the inequality without the absolute value sign, and then you're going to write a second inequality without the absolute value sign, but this time you're going to flip the inequality sign and take the opposite of the quantity on the right. Then you will solve each inequality separately, sketch the graph of each inequality separately, and then determine if it will be an and or an or inequality and graph the final inequality. Also, to review, if it's a greater than or equal to sign, it's greater than, so it'd be a divorce, as we can see. And if it's less than or equal to, it's like a sandwich, so we're going to shade in the middle. In this example, we have the absolute value of x plus 7 is less than 12. In order to solve this, we first have to get the absolute value by itself. So we're going to wrap it up like a present. So we have the present plus 7 is less than 12. To solve to get the present by itself, you would have to subtract 7 from both sides. So you'd have the present is less than 5. Now that can be rewritten as the absolute value of x plus 7 is less than 5. Now we can use this to write our two inequalities. So we'll have x plus 7 is less than 5, our original inequality without the sign, and x plus 7 is greater than negative 5. Where in this case, like we talked about yesterday, you are flipping the inequality sign and making the number negative. Now you're going to solve each inequality like you normally would. So to solve the first one, I would subtract 7 from both sides to get x is less than negative 2. And to solve the other one, you would subtract 7 from both sides to get x is greater than negative 12. Now if you were to graph them separately, we're going to shade just part of the graph. So for x is less than negative 2, we'll have an open circle at negative 2. We're going to shade a little bit to the left. Then for x is greater than negative 12, we'll have an open circle at negative 12, shade a little bit to the right, and then we can see that these graphs are going to run into each other. So I'm going to finish my graph. So we should have open circles at negative 2 and 12. Shade the entire part in between, and you could rewrite this as a compound and inequality. So negative 12 is less than x is less than negative 2. For our next example, again, we're going to wrap it up like a present and solve to get it by itself. So we'll have negative 7, the present, is less than negative 77. Now this negative 7 is really multiplied by the present. So in order to get the present by itself, you have to divide both sides by negative 7. However, when you divide by negative 7, that means that you have to flip the inequality. So if I were to rewrite this, it's not going to be the present. It flips to greater than or equal to, and it becomes 11. Again, because of the fact that we're dividing by a negative, we have to change the inequality sign from being less than or equal to greater than or equal to. Now we can rewrite this as the absolute value of v plus 6 is greater than or equal to 11, which we can write as our two separate inequalities. So we'll have v plus 6 is greater than or equal to 11, and v plus 6 is less than or equal to negative 11. Now to solve to get the variable by itself, for the first one I would subtract 6, So you'll have v is greater than or equal to 5. For the second one, subtract 6. So you'll have v is less than or equal to negative 17. Now you're going to graph them separately. So for v is greater than or equal to 5, you'll have a closed circle at 5 and sketch part of your graph, so it's going to the right. For negative 17, we're going to have a closed circle at negative 17. Sketch part of our graph, which is going to the left. And now we can see our graphs are going in opposite direction. So we can finish our graphs by extending the arrows in both directions and rewriting as our compound inequality. So v is less than or equal to negative 17, or v is greater than or equal to 5.